Hi, today I'm going to discuss my findings from a literature review conducted to provide an understanding of what we currently know about autism spectrum disorder, ASD, the use of transcranial direct current stimulation, TDCS, and its emerging efficacy as treatment. The use of electrical stimulation in mental health treatment has a long history, dating back to the Greco-Roman period. Today's practice has evolved into transcranial direct current stimulation, or TDCS, which is gaining popularity as a promising therapeutic option. ASD is a neurodevelopmental condition characterized by challenges in social communication, repetitive behaviors, and restricted interests. It affects individuals across a broad spectrum from low functioning to high functioning and significantly impacts daily life, well-being, and long-term outcomes. Our current understanding of the physiological mechanisms of ASD reveals it as a neurobiologically complex and heterogeneous condition and manifests differently across individuals. Neuroimaging techniques such as functional magnetic resonance imaging, fMRI, have been instrumental in uncovering abnormal brain areas and atypical functioning. It has been consistently found that there is altered brain connectivity in individuals with ASD compared to neurotypical. Leading theory of ASD hypothesis that it is differences in the amygdala that contribute to social dysfunction through abnormal activation. While several studies indicate that the amygdala is hypoactivated in ASD, a large-scale study by Kleeman et al. In 2024 found no reliable differences in its functional connectivity. Wang and Lee 2023 point out that amygdala differences only account for some deficits in ASD. An alternative view is a network perspective. The default mode network, particularly the posterior cingulate cortex and medial prefrontal cortex, show noticeable differences in ASD. The DLPFC also exhibits functional deficits. Additionally, atypical connectivity between the cerebellum and prefrontal regions suggests that ASD affects more than just cortical areas. Abnormal activation patterns in the mirror neuron system are linked to deficits in imitation and social interaction, with interactions between the MNS, amygdala, and prefrontal cortex potentially exacerbating social deficits. The main hypothesis for these impairments is an excitation-inhibition EI imbalance. This occurs when excitatory signals dominate due to high glutamatergic activity or insufficient inhibitory GABA signaling, leading to cortical hyperexcitability or underactivity. This disruption in the EI balance impairs synchrony and communication between brain networks like the DMN and DLPFC, contributing to the cognitive and social challenges seen in ASD. In Figure 4, we can see that the treatment is designed to improve the connections between neurons by increasing or decreasing the amount of glutamate or GABA neurotransmitters being released between synapses. Figure 5, we can see an example of a TDCS system. It works by passing a weak current of 0.5 to 2 milliamp across the cortex using 2 electrodes, typically applied for 10 to 30 minutes over several sessions. And in Figure 6, these electrodes are either anodal or cathodal, and their placement depends on the treatment goal. The anode excites neurons while the cathode inhibits activity. The key challenge for researchers has been the limited understanding of neural mechanisms and the correct dosage for consistent behavioral outcomes. We do know, referring to Figure 7, that anodal stimulation works by depolarizing neurons, making it easier for them to fire, which strengthens weak synaptic connections. The goal is to balance the EI imbalance. TDCS modulates the EI balance in brain circuits through either enhancing glutamatergic signaling or promoting GABAergic inhibition. Cathodal stimulation, see Figure 8, whilst less studied, has shown promise in reducing symptoms like irritability and hyperactivity in ASD. It works by decreasing neuronal excitability, promoting inhibition, and enhancing connectivity in areas like the medial prefrontal cortex, which supports flexible social cognition. The most common TDCS protocol used in the studies reviewed involved anodal stimulation of the left DLPFC with a cathode placed on the shoulder or supraorbital areas. Meta-analysis support the consensus that anodal stimulation of the DLPFC shows improvements in ASD. Alternatively, cathodal stimulation of the cerebellum was also used and found to reduce symptoms. In an interesting study by D'Urso, see Figure 9, it was effective in improving sleep disturbances among children with ASD. One major issue is that TDCS effects are often task-specific, with improvements in certain tasks not leading to overall behavioral changes. The lack of female participants in research complicates understanding of gender-specific outcomes. Side effects of TDCS TDCS, such as itching, burning sensations, and headaches, are generally mild but common and will be crucial when treating sensitive populations like children. Brain connectivity in ASD evolves over time, with children and adults showing different connectivity profiles. Generalization of TDCS effects across brain regions raises concerns about unintended impacts, as stimulating or inhibiting specific areas may improve some ASD symptoms, while negatively affecting other positive savant abilities or disrupt interconnected networks. Investigating the interaction of TDCS with pharmacotherapy and integrating robots as a therapeutic device are promising avenues for development. Future research should focus on task-specific effects, individual variability, and evolving brain connectivity, employing a network-based approach that enhances targeting by focusing on communication between regions like the DLPFC and DMN. Large-scale standardized trials are essential to refine protocols, optimize stimulation parameters, and identify subgroups that benefit most, ensuring inclusivity by including females and matching participants with similar baseline cortical states. Validating TDCS as an effective treatment could represent a significant breakthrough, offering new hope for individuals with ASD and their families.